Here's another example question. It says a passenger jet flies due east from point A. So a passenger jet is essentially a plane, an airplane. Anyway, it flies due east from point A, latitude 60 degrees south and longitude 20 degrees west, to a point B, which is at latitude 60 degrees south and longitude 70 degrees east. So we're flying from A to B, and we know the positions of point A and B on the Earth's surface. Now, given that the plane moves at an average speed of 600 kilometers per hour, we are required to determine the distance between point A and point B and the journey time along the flight path from A to B. So latitude 60 degrees south would be somewhere to the south of the equator. So if we just have the equator and this is the prime meridian. In fact, I'm just going to use a solid line. This is the prime meridian, assuming this is the prime meridian. So latitude 60 degrees, the line of latitude that contains all points with latitude of 60 degrees south will be somewhere here. And the other, okay, yeah, so we have that. So I know that point A lies on this line of latitude 60 degrees south. Point B also lies on this line of latitude. But where's A and where's B? Well, the longitude of point A is longitude 20 degrees west. So 20 degrees west from the prime meridian, somewhere here. So point A is somewhere here. Point B lies at longitude 70 degrees east, but it's on this line of latitude. So from prime meridian, I move to the east, I cover 70 degrees, so will get me somewhere here. So this is point B. This is the center of this small circle of this latitude. So you can essentially form this sector. If you look from the bottom here or the top, assuming you can see through this sphere, and you're looking at this region here, you would see this circle representing, or the circle containing all points with a latitude of 60 degrees south. Point A somewhere here. Point B will be somewhere here. This will be the center. Distance from the center to any point on the circumference is equal to small r. Right? So essentially what we have is a sector. There's some angle formed here. Now, if I call this point here where the prime meridian intersects with this line of latitude, if I call that point P, I'll show that point P here. Now, the angle formed from P to A is the longitude of point A. The angle formed as one moves from point P to point B, the angle formed is the longitude of point B. So this angle here is 20 degrees, and this angle here is 70 degrees. So that's a bit small, so that's 70 degrees. So all I'll do is just give you a larger sector. This is what we have. What's the total angle here? 90 degrees. So plane is literally flying from point A to point B, so it's moving along this path. That's the same thing as moving from A to B on this sector. So this is just a top view. What is the distance between point A and B? That's the same thing asking for the length of the arc AB. This radius is R. So how do you find the length of the arc? If I call this arc AB SAB, so this arc has a length SAB. How do you find the length of an arc? The length of an arc is equal to the angle formed in the center of the sector, so theta, divided by 360 times 2 pi times the radius of the circle the sector is from. In this case, that's small r. You know that small r is big R cos theta lat, where that's the theta lat is the latitude of point on the circle where this sector is cut from. And this circle is this small circle here, and this latitude is the latitude of points on this small circle is 60 degrees south. It's all given in the question, the problem statement. So that means the distance traveled, this SAB, is equal to the angle formed at the center of the sector, which is 90 degrees, divided by 360 times 2 pi times small r, which is big R, times cos theta lat. What's the latitude of point on this circle, or what's the latitude on the point on the circle where the sector is from? Well, the latitude is 60 degrees south, so it's 60 degrees. So you can simplify this, because this means the distance traveled is given by 9 here 1, 9 here 4, so that's 1 over 4 times 2 times what's pi? 22 over 7. Big R, 6,400 kilometers, times the cosine of 60, which you know is half 1 over 2. So simplify this using a calculator will give that distance is approximately 5,027 kilometers. So that's question 1 done. Why is it kilometers? Because if you look at the equation, this R here represents the only length in this equation, and it's in units of kilometers. This 6,400 is 6,400 kilometers. I just thought to emphasize that so you know where the unit comes from. So question 2 says determine the journey time along the flight path. So I'll just move here. We know that speed, or average speed, is equal to distance over time. So time is equal to distance over average speed. Distance traveled we now know is approximately 5,027 kilometers, and the average speed was given as 600 kilometers per hour. So what's the journey time? It's simply approximately 8.38 hours, which can be, that's the same thing as 8 hours and 0.38 hours, which is the same thing as 0.38, 0.3 hours times that's 60 minutes. 60 minutes is equal to 1 hour. So I could do something like this. Essentially 0.38 hours a minute is given by this, 0.38 times 60, which is equal to 22.8 minutes. So I'll say that's approximately 23 minutes. So it's 8 hours and 23 minutes approximately. That's the journey time. Here's another example question, and it says a passenger jet flies due north from point A, located at latitude 60 degrees south and longitude 20 degrees west. It flies from point A to a point B, latitude 60 degrees north and longitude 20 degrees west. Given that the journey takes 27 hours, determine the distance between point A and B. So it should say determine and also determine the average speed of the passenger jet. So let's just focus on case 1. First thing is to do, let's locate point A and point B. So it's always a good idea to show the equator and the prime meridian. I'll just use a solid line for that. So that's just my version. Point A lies at latitude 60 degrees south and longitude 20 degrees west. Latitude 60 degrees south, that's to the south of the equator. It's going to be somewhere here. So A lies on somewhere along this circle, but at longitude 20 degrees west. So 20 degrees to the west of the prime meridian, that's going to be something like this longitude. So essentially what I have is point A here. Point B is on the same longitude, 20 degrees west, but at latitude 60 degrees north, which is going to be to the north of the equator. So point B lies in the section of this line of longitude and this line of latitude. So this is point B. center of the equator and the center of the sphere, point O, so I can form a sector, as you can see. So I'll just do that again. And there's a sector, and if you just look in, say you're looking from, so again, you imagine you could see through the sphere and you're looking in this direction. Essentially what you see is this sector. It's point O, point A, actually point B, that's the point B here, and point A down below here. So what do we know? We know that the latitude of A is 60 degrees south. That means that if I draw a line from O to A, and I locate a point directly above A, that's on the same plane as the equator, the angle formed between such 2 points, so this is a point directly below A, is equal to 60 degrees. And that's this angle here. Similarly, point B, which is on latitude 60 degrees north, point B is such that the angle formed between this line OB and a line that's on the same plane as the equator but that lies directly below B is also 60 degrees. It's hard to see here, so I'll show you here. So what we have is a sector where the total angle is 120 degrees. So what we have, that's B, this is point A, this is point O. This angle here is 120 degrees. So what we need to do is find the distance between point A and B. We need to find the length of this arc. I'll call this SAB. SAB is simply given by the angle from the center of the sector divided by 360 times 2 pi times the radius of the circle where the sector is from. What's this radius? Or what's the length of OB and OA? It's big R because point B and A lie on the surface of the Earth, and you know that the length of any line from the center of the Earth to a point on the surface is equal to the radius of the Earth, big R. So we have big R here. That means that SAB is equal to 120 divided by 360, same thing as 1 over 3. So there's a degree sign there. Anyway, 12 here, 1, 12 here, 3. So it's 1 over 3 times 2 pi R, 2 times 22 over 7, times what's R? 6,400 kilometers. That means that length of the arc, AB, is approximately equal to, you can use your calculator and you get it's approximately equal to 13,404 kilometers. Question 2, the part 2 asks for the average speed of the passenger jet. As you know, the average speed is going to be equal to the total distance traveled by the jet divided by the total time taken. We just determined that the total distance is equal to 13,404 kilometers, and that the total time taken for the journey was given as 27 hours. That was given. The journey takes 27 hours. So our average speed, which I'm going to call, well, I'll just call it speed. Or just to be consistent, I'll just continue with average speed. The average speed is going to be equal to whatever you get when you divide 13,404 by 27. And you can use your calculator and you get that the average speed is equal to 496 kilometers per hour. And that's all. Here's an example question on the rotational speed of a point due to the rotation of the Earth. So it says, calculate the speed of point X, which lies on latitude 40 degrees north, due to the rotation of the Earth. So if I just locate a line of latitude to the north of the equator, I can just say that point X lies somewhere on this line of latitude. To solve this problem, you don't need to know the longitude of the point, you just need to know the latitude. So point X, I can just arbitrarily assign a location for, and I'm saying that the latitude of this point, so the equator, is this line of latitude here. Well, so if this point here is the center of the Earth, so point O, and a point directly below point X that lies on the same, well, basically lies on the plane of the equator is point P. A line from point O to point X and a line from point O to point B have an angle between them, and this angle is the latitude of point X, and that latitude is 40 degrees. So that's where 40 degrees north comes in. So point X lies 40 degrees to the north of, well, the line of latitude of point X is 40 degrees to the north of the equator. So as the Earth rotates, point X moves from west to east. So it moves along this circular path, and it covers a certain distance, and that distance is equal to the circumference of this line of latitude. So what we have from a top view is this line of latitude, which is a circle, so this one here in white. Point X lies somewhere on the line. This line of latitude has a certain radius, and we're interested in finding the rotational speed of point X. So let's start from there. So I'll call this speed R, I'll say rot X, the rotational speed of point X, and that's equal to the distance traveled by point X during a complete rotation divided by the time it takes. So what is the distance traveled by point X during a complete rotation? That's simply the circumference of this circle, which is 2 pi r. 2 pi the radius. What's the time taken for point X to undergo a complete rotation? What's the time taken for point X to start from this point and move along the circular path and get back to its starting point? Well, that time, as you know, is 24 hours. So pi can be taken as 22/7. 2 is just a number, 24 is a number. So r is unknown. The radius of the line of latitude here is unknown. So in order to determine the radius of any line of latitude, all you need to do is use the formula r equals big R cos theta lat. So for a certain line of latitude, which you would know the angular value of the latitude, so if a point lies on a certain line of latitude, you need to know the latitude, you need to know the angle. So in this case, it's 40 degrees. And once you know that, you can find the radius of that line of latitude by using this equation. Big R, as you know, is the radius of the Earth, the radius of the equator, which is 6,400 kilometers. So this can be written as, well, I'll just stop there for now and replace small r with this. So the rotational speed of point X is rotational speed is equal to 2 pi small r, which is 2 pi. What is small r? Small r is r cos theta, big R cos theta lat, so all of this divided by 24 hours. So the question now is to determine this rotational speed. The rotational speed of point X is therefore equal to 2 times pi, which we can take as 22/7, times big R, which is 6,400 kilometers, times the cosine of the latitude of point X, which is 40 degrees, well, the cosine of 40 degrees. And all of this divided by 24 hours. So up here we have kilometers and down here we have hours. So just do kilometers per hour. Kilometers per hour. So this simplifies to give, you can use your calculator. I guess I'll just try and take you through the steps. 2 times 22 over 7 is 44 over 7. 44 over 7 times 6,400 is 281,600 over 7. So it's all of this times the cosine of 40 degrees, which you can determine using a calculator. So it's all of this divided by 24, which simplifies to give approximately 1,284 kilometers per hour as the rotational speed of point X due to the rotation of the Earth.